Hi, thank you for watching the product introduction video for the Trimble Access Powerline module. My name is Nico, and I hope this short video gives you an overview of the Powerline application, a streamlined application targeting the day-to-day work of survey crews that want to measure the sag of a cable. Its focus is on reliable and easy-to-use workflows that produce consistent results. So let's get started. We will first go through a couple of slides giving you some basic information on the application, then have a look at the technical side, ordering information, and last but not least, a live demo. Trimble Access Powerline is designed to deliver fast and reliable results that are reproducible over time. If you measured a power line before, you might know it's sometimes tricky to compare results from different campaigns or jobs. That's where Powerline comes into the game. To accomplish this, Powerline lets you easily measure key points on a power pole, like conductors, etc. It helps you creating lines through those key points, which are rough estimates of your true cable. In the end, it will let you stake out the line elements with angle measurements, so you don't need a distance reading. The height gets adjusted via aiming at the cable after the total station has driven to the stakeout point. So the operator only adjusts the vertical angle of the gun. Everything else is done in software. There's a bit more to the workflow, but we will see this later on. Powerline, like all other modules for Trimble Access, integrates seamlessly into the existing portfolio of solutions. So it's straightforward to share data between different modules. Due to the same layout and look and feel, there's also a very low learning curve. Existing users of Trimble Access will feel familiar immediately. New users will find the guided workflow in Powerline easy to use as they guide the operator through each step of the workflow. Talking about workflows, the idea behind the Powerline application, or more precisely the workflow, is based on the input from Jim Preen and his son Justin out of spatial data surveys. Jim and his team provided us with their expertise and their existing workflows, as well as the problems they have with it. Based on this input, we try to improve the workflow, streamline it, and make it available for other users as well. So we also want to express our thanks to Jim for his patience and explanations, as this is the way customer-centric development should happen. Getting back to the application. How does the core of Powerline work? I have mentioned parts of this already. Basically, we have two components here. The first part is a structure measure form for measuring points of interest on a structure. Next to some default instrument configurations, it provides access to so-called routines. These routines trigger additional actions later on. The second part consists of the plane creation and stakeout workflow. In this workflow, we create a list of lines based on either routines or manual input. These lines will be used for stakeout later on. Afterwards, the segments of the line get stakeout, exported, and we are done. That's it, more or less. So who can use this software? We think that anyone working for utility and electricity companies might be interested in this. Everyone who wants to estimate the sag of a line on a regular basis will benefit from Powerline due to reproducible results it delivers, based on fixed segments and easy to use, straightforward workflows. Now some more technical details. This would be the default workflow you perform in Powerline. We will see this later on in the video. First, we create a job and configure it according to our needs. Then we perform our station setup and measure our structure points. Based on selected routines in the structure dialog, we have a list of virtual planes, which we can subdivide. These segments will be used as stakeout points. After the line got staked out via angle measurements, we perform backside checks to confirm that our station hasn't moved during the process and to be sure we have good results. At the end, we export our data to whatever format we need. So if we take a look at the measure button, we will see exactly those steps. I won't go into the details now because we will see this later. Here you get an idea how the structure dialog looks like. Most important is actually the routines dropdown, as this is a trigger for further actions. We will see this later on as well. The line definition and stakeout workflow can be seen here. The definition form gives us the option to review the virtual plane, to check the total length as well as the segment length. After we accept the line, we go directly into the stakeout form, in which we can see the 3D position of our real cable and the difference to the virtual plane. We can measure all segments as defined previously and cycle through all measurements later on to verify we measured the correct cable. So in the end it looks like this, assuming the pole separation isn't too big. So to summarize what we've just seen, Powerline gives us a straightforward, easy to use workflow for measuring the seg of a cable. Due to its simplicity and the setup, the results are reproducible and will increase your productivity. Last but not least, the part number for Powerline is TAA-Power-Line, and it's also available as a trial version via the Trimble Access Installation Manager. Now, let's switch to the demo. What you can see here is the latest version of Trimble Access, namely 2014.10, running on a Trimble tablet. But before we get started, let's define what we want to do, or better, how our scenario looks like. So this is our current surrounding. We have two power poles at a separation of around 207 meters. We want to measure the seg of one of those cables. So the seg of this cable essentially. That's the task for today. So let's get started. Obviously, the first thing I have to do is to create a new job. In this case, I just call it Powerline and create it. Everything is basic, so there's nothing inside, no points, nothing. To take control of the site, I'm now importing a couple of points out of a CSV file. That's a file I've created before. In this case, I'm just importing 3 points, which I will use for my resection later on. So let's quickly do that. I'll create my station setup, select resection, and this is all pretty similar to what you know from Trimble Access or its other modules. So these are like shared components which look the same in all Trimble Access applications. I'm now speeding up this process a little as it's, as mentioned, nothing special. The only important thing to notice is that I'm using 3 points for my resection, as this might be interesting later on. So I'll just do this stuff and we will have a look at our site setup in a second again. And we are done. So this looks more or less okay. Before we start our pole measurements, I would like to give you another idea how our surrounding looks like. So I'm just turning on the camera and I'm now looking at pole number 1. And I will now drive to pole number 2. And our target is to measure one of those lines and determine the seg of the line. That's the pole number 2. To give you an idea how the measure menu of Powerline looks like, it's actually pretty similar to what you know from Trimble Access. Of course, you can either switch to Trimble Access General Survey and use the typical measure functions available there, or you can also reach them via the fields inside Powerline. The more interesting ones are for now measure structure, measure Powerline, measure backside, and maybe pole center location, as those forms create our workflow. So let's start with measure structure. The structure form is essentially used for all measurements on a pole. It can be used for normal topo measurements, but this is nothing special. We can also switch directly to the video screen and check our measurements. Note that the instrument is automatically turned to tracking and DR measurements while entering the structure form. The whole thing gets more interesting when you look at the routines and methods drop-downs. In the routines, we have essentially triggers that launch further actions. Methods are similar to what you know from General Survey, so the typical angular distance or distance offset methods. In this first step, I select circle calculation and I will measure 3 points on the power pole. These points will be used to perform a circle calculation to get the center of my power pole. So in this example, I have already measured some points for circle calculation, and I will now do the same. So the CI points, I can use either my default measure form or I can use the video screen to measure inside the screen. And I've measured C1, C2, and now C3. And after stirring point number C3, you can see that automatically the pole center location form pops up, which is used to visualize and to review the point or the center of the pole. We can check the map and see how the calculation matches our measurements. So this looks correct. Sweet. As our pole center calculation is done now, we can now switch to something more interesting, the line measurement. For that purpose, I'm first defining a useful point name, and I'm switching to none routines. We will see later on why. I'm now going to the video and just measure the first line. Because it's so close, I can directly measure it via the arm measurements in the video screen. I see a distance measuring at the bottom and just press measure and my point gets created. Next, I want to record another starting point of a line. For that purpose, I'll again change the name to something meaningful, how I can, let's say, differentiate between my two lines. And I go back to the video screen and aim at the top of the cable, or at the top of the pole actually. You can see the bird landing there. I'm now going back to the measure form and I'm selecting routine, in this case virtual plane. This means the point I'm creating now will be used as a start point for a line. This dialog here is actually quite important because it lets you choose between new point and select point. Remember, I've just recorded a point with the virtual plane method enabled. That means I've created a starting point for my line. If I select new point, I can measure the end point. If I select existing point, I can select the end point of my line. In this case, I've just swapped over to the other pole and I will now measure the end point of my line. So I've selected new and I will now shoot the point. For the purpose of the demo, I'll also select a method, in this case the angle offset method. That means I'm first aiming a little bit below my true cable because it's easier to measure, and then I'll just correct the angle of my total station to get a correct angle reading. After starting my point, we also get the information that the line was successfully created between point 20 and 21. Before we continue, let's reflect on our workflow. First, we have measured point line 10. This was without any kind of method. Next, we have measured point line 20 with the routine virtual plane enabled. This means line 20 is the starting point of our first line. Now we've selected new point, so the end point for our line will be a new point that is not in memory so far. We are aiming at the topmost point of our second pole and shoot it. So the first line is created inside our memory. Now I'm aiming at the second point of interest on our second pole. I call this line 12. We will see this later on. And after measuring point line number 12, I will connect that with the existing point line 10. So in the end, I have two lines in memory, one between point line 20 and point line 21, and the other line between line 12 and line 10. So let's continue with our workflow. As mentioned just a minute ago, I'm typing in point number 12, which will be the start point of my second line, and I will again use the angle offset method to record the point. This is just to make my life a little bit easier. After starting the point, I have the selection to choose or to measure either a new point or to select an existing point. As mentioned, I will now switch to select point and select a point out of the point list. In this case, point line 10. Pressing store and a line will be created. These are all lines I want to measure for now. So I just verify that my points look good. And now I press the next button. The next button essentially launches the next step in my workflow. This step now is the line definition process. Here I can define my line, can define default feature codes for my line elements, can define the amount of segments, and I also get an immediate idea of the total line length as well as my segment length. Assuming I'm happy with my configuration, I just press next again, and I'm now in the stakeout screen. The stakeout can be performed in two different ways, either via the traditional stakeout form or via the video screen. In this case, I'll start with a video. So my total station automatically turns to the first segment of the line, and the only thing the operator has to do is to adjust the height of the gun. So we can see here, the station turns to the second point. I'm just correcting the height. So I'm aiming at the true cable I want to measure, and I accept the point via pressing measure. Come on. Measure. Compared with the video stakeout, the traditional stakeout contains more information about my true cable. We can see the northing easting elevation of our currently measured element or segment, as well as the difference to our virtual line. Otherwise, the workflow is exactly the same. So I'm iterating through all elements or all segments of my cable and measure those. The only thing the operator has to do is to adjust the vertical angle. After all segments are measured, which we see at the top with our segment counter, we can cycle through all measured segments. This is important to do some kind of quality checks or testing on all measurements. It's sometimes tricky to really get the correct cable, especially if you have more than a couple of those on the pole. Therefore, this cycling through the existing measured points is quite helpful. You can see here, that's point number 13, 14. These are all our stakeout points or our measured points on the line. So this is an easy way to check that your records have been correct. After pressing the next button, we have different choices. If we have another line in our memory, we can press next line. Otherwise, we can either go to the structure definition form, to the line definition form, or we can continue with backsides. In this case, because we have another line in our memory, we just press next line and continue our line measurements. The measurements are similar to the ones we've done before. So it's again the stakeout workflow, either via the video screen or via the normal stakeout view. To speed this process a little bit up, I'm just using the normal stakeout. The stakeout process of my second line is exactly as before, so nothing has changed here. I'm now measuring all my elements, I'm checking them, and when pressing the next button, I will have three options. Remember, I have now measured all lines in memory, so the measure next line is not available anymore. Because I'm done now, I select backsides. I will now measure all my backsides and check for changes in my stationing. Backside 1 looks good, so my total station automatically turns to resection point number 2. I'm checking the accuracy here. We see same, so pretty good results. And last but not least, resection point number 3, also very good delta values. I've measured all my backside points, so I want now to export. Of course, I can use any kind of export, but with the Powerline application, we've implemented a special style sheet that, let's say, helps you also in the field because it visualizes your data. So what you see here is an HTML export of the data. On top, we have each line on a plot, and of course we also have the values in a table. We can compare each line. We have an immediate visual indication if my line measurement was okay or not, and I also have the table. I have to mention that this export only works on the Windows tablet PC and not on Windows CE devices, because it uses stuff like HTML5, so modern features of a browser that are not supported on CE devices. Still, it's a nice and easy way to check for, let's say, accuracy or if my points have been good. We are more or less done with our line recordings now. So the last thing I would like to do is take some photos of our power poles to document our work. So that's power pole number 2. I also turn to pole number 1, take a photo, and that's it. This is all about Powerline in the moment. I hope you enjoyed the presentation and learned a little bit about Powerline, its workflows, and how it might help you in your daily work. Thank you for watching.